complicated, and we start off with a car that is in itself very complex. A Formula One racing car has a chassis which is made up of about 11,000 components. The engine's about 6,000. The electronics is another 8,000. So there's 25,000 things that have to come together and work in order to be successful. Now, how do you keep 25,000 things in your head at the same time? Well, the answer is you don't. And so Formula One is very much data-driven. So it's a matter of understanding what it is you've built and being able to turn data into stories from which you can take action. Now, when you build a car, it's 95% new at the beginning of the year, and then for the rest of the year, you're developing it to make it faster. So at the sharp end of a Formula One grid, there is something like 2,000 to 3,000 to 4,000 components being built every week of the year. Every 20 minutes, a new part is being designed. So that is the pace of development that's going on in Formula One. It is the closest thing in a mechanical forum that I've seen to software development, where you have new releases happening all the time. So, how do you start understanding what's going on? Well, the answer is sensing. You put a lot of sensors on the car. In race trim, there's about 120 sensors measuring different things to do with how the suspension operates, how the aerodynamics works, the state of tires, etc. And you're measuring that data and sending it across in real time back to the garage and across the world so that the engineers can, in real time, get an understanding of what's going on. Okay, so that's quite simple. We put a few sensors on a car and we grab the data. But these cars are running around the track at up to 200 miles an hour in some very interesting terrain. Now, there's a race coming up this weekend in Monaco, and immediately, if you look at the picture of the circuit, you can see that it is not straightforward to be gathering information. You're going around a circuit which is in a city center. There's a lot of water around. There's a lot of soft bodies to absorb radio waves, spectators, trees. And so how do you actually get the data from the car to the garage? Well, the answer is the same way that we use wireless networks for telephones. The only difference being we arrive at the circuit on a Tuesday. All of the fiber optics will be put around the track for the television. We'll then put 6 or 7 antennas around the track, access points, and they will be in place by Wednesday evening. On the Thursday, when the safety car goes around, we'll test that the system's working, and then on Friday, we start racing. And so we create a little city in a very short length of time so that we can go racing on the weekend, so the hundreds of millions of people who watch it on television can see what's going on, and so that we can see what's going on in our car, which has never raced in that format before the Friday morning of a practice session. So, a message about innovation. One of the reasons it works in Formula One is there's a very clear reason for success, because if you don't innovate, you don't win races. The other side, I'm not sure whether this is stretching the open innovation too far, but actually innovating in the public eye is a very good way to keep yourself honest. When you have hundreds of millions of people watching what you put on the track, you better get it right, and if you don't, you better fix it pretty quick. Okay, so what happens with the data? Well, in the back of the garage, there are engineers who are looking at the data coming from the track. We're sending data at a rate of between 2 and 4 megabits per second from the car. What that means is in a 2-hour race, there will be about 750 million numbers coming across in real time. The engineers are looking at that data, and what they're trying to see is how our patterns are changing. So are there things which are unusual? So there's about 500 parameters being sent from the car at rates up to about 1 kilohertz. There's also a lot of health parameters being detected within the vehicle. we're sending about 13,000 health parameters and events across from the embedded systems on the car back to the guys in the garage. And this is providing intelligence at the edges of the network to say, you might want to look at this, there's something happening here. But it's more than that, because with this level of data, it's too much for any one of us to be able to see everything. And so we're running simulations in the garage when the data comes through. So if you're watching a telecast and you hear them talk about saving the engine, it's just not rhetoric. What they're doing is they're taking the simulations that are going on in real time in the garage of how much life is left in the engine based on the telemetry information which is coming through. So the important message in terms of data is if you're going to collect a lot of data, that's not enough. You need to be able to turn it into a way of making decisions so you can act upon the data. And one of the great challenges that we see in all walks of life, and we've been dealing with it in Formula One for 20 years now, is how do you turn data into stories from which you can decide to act? And the quicker that you can make sense of what you see, the quicker that you can make a difference. But it's not just the guys in the back of the garage who are looking at data. One of the wonderful things about the internet is that we no longer have the situation where the thing that you're controlling or looking at has to be in the same location as you. So we're sending the data back from the garage through to the factory, which can be on the other side of the world, into what we call our mission command. But it's essentially replicating what's happening in the garage in a remote location, in this case, the factory. So we're able to look at the data for our racing car to decide how best to optimize its performance on the practice sessions on a Friday, on a Saturday, so that we can have the best chance of success in racing on the Sunday. But you're not racing against yourself, you're racing against competitors. So how do you understand what your competitors are doing? Well, you haven't got the same rich data source as you have of your own vehicle, but what you do have is measurements of their lap times. You also have images that you can see on television about how the cars are performing. So if you just take lap times, if you take this information and you look at it differently, you look at it from sideways, you look at it from all different directions, it's actually very rich in information about what your competition is doing. So throughout a race weekend, from the practices on the first day through qualifying and racing, you're not only trying to understand your own car and make it as fast as possible, but you're understanding your competition. How does their car react with new tires? What happens when the tires start to degrade? How much faster are they than your car? How much slower? And so throughout the weekend, you're creating a knowledge base on the competition so you have the best chance to beat them. So the essence of creating the strategy is understanding yourself very well and trying to infer from the information which is available what the competition is doing. There are actually a lot of races run during a race weekend. There are virtual races, simulations of what's happening at the racetrack, thousands of simulations every second. And this is so that you can store your decisions beforehand so that if something happens that you've thought about before, you can act quickly. So the essence of IT systems in motorsport is try to embed knowledge into systems so that you can retain your intellect to deal with surprises. And there are enough surprises. You would think 22 cars going around a track, the same track every direction. You know, there can't be too many things that happen that you don't expect. And then you have the first corner, and two cars collide and the whole thing changes. Or you have what we have this season where the tires degrade a little bit quicker than you might expect. And so there are more pit stops. There are a lot of things happening in a structured environment of a racetrack. And so when you move outside beyond the racetrack into a much more unstructured environment, it just becomes more complicated. but the essential message is the same. There's plenty of things that you can measure to understand. If you can bring that information together, that's when things start getting interesting. And that's when you can start building new applications to bring data together to get a better understanding of the world around us. And that better understanding allows us to adapt. Now, our main business is motorsport, but we also translate some of our knowledge into other industries. And by way of example, there's a train there. This is a train in San Francisco, the Bay Area Rapid Transit System. What we have done there is we've taken our telemetry system, which is a number of antennas around a set track, and we have put wayside antennas along the railway line. So we have a Wi-Fi corridor, if you like, a big pipe into the train, which allows us to look at video images from within the train, which is interesting from a homeland security perspective. It allows us to take diagnostic information off the train, so we can look at maintenance and availability in real time. And it also allows us to provide passenger internet for the commuters. So from what starts at a fairly simple beginning, which is let's provide infrastructure so that we have a data pipe to a moving vehicle, suddenly becomes quite a rich proposition. And once that infrastructure is in place, there are many other things that we can imagine, that others can imagine to build upon that data. I've also shown a picture of a baby up there. We have put one of our Formula One data systems into the intensive care unit and child transport ambulances at Birmingham Children's Hospital. And what we have done is release the ability to be able to store and collect data from the sensors on these acutely ill children and allow the clinicians to create the means by which they can extract patterns from the data. And the reason for doing it is very clear. If you can look at the patterns in the data, look at the same data in a different way, it gives you the chance to detect when things start to deteriorate. And if you can see things going badly early, then you can get a child in front of the right person in the right place. It's a little bit like our racing cars. You have a very short time in which you can make a difference. If things start going wrong and you detect it, you may be able to save it. If not, then you have a problem. And it's the same with the sick children. If you can detect conditions early, if you can stop a cardiac arrest from happening, you can save the child. And so I guess the message there is where you start innovating, maybe for a very specific reason, in our case, is to make cars go faster. If you look carefully, you can often find areas in which you can translate it into other areas. But as importantly, if you expose it to others, if you let people see what you're doing, then they can have ideas and they can see how they can translate it into their own business. We didn't go into the railways or the hospitals because we suddenly had an epiphany where we said, actually, now we understand everything about medicine, now we understand everything about railways. Although I do tell our doctors at Birmingham that having been working with them a year, because I come from motor racing, now of course I'm an expert in medicine as well. But the point is, if you can expose a way of looking at things to someone who has close domain knowledge of their own industry, that's when things start becoming interesting. And that's the essence of open innovation. Thank you very much.